you have a big exam coming up, or maybe a presentation at work, and you need to understand a difficult topic fast, it might seem like an insurmountable challenge. But I am here to tell you that there are scientifically proven ways that could make this process much easier and faster. Today we will explore evidence-based techniques to help you grasp difficult concepts faster and more effectively. Then at the end we will look at common mistakes that greatly reduce the efficacy, if not completely hinder, learning difficult topics. First we will get an overview of science-proven learning techniques. Then I will tell you how I used them to perfect my learning in college to help me not only ace my test, but also earn the bonus points. Many of these techniques I still use now in my professional life, as I continuously need to learn difficult subjects in short amounts of time. The first technique I would like to talk about is active learning. Our brains are not designed to sit through endless lectures and cram enormous amount of information into them. For example, there was a study published in the journal Science, which is one of the most prestigious scientific journals, that compared the performance of students subjected to the traditional lecture-based format to those who participated in a redesigned course with increased structure and active learning components, such as daily and weekly practice with problem solving, data analysis, and other higher cognitive tasks. This was in the context of STEM courses, for example, college-level introductory biology. And they found that this method significantly improved the performance of students attending the redesigned course. In addition to reducing the achievement gap between students who come from disadvantaged socio-economic backgrounds and non-disadvantaged students at no additional cost. This and other studies show that we learn best by engaging with the material. For example, by discussing concepts in a group, asking questions and answering them, or engaging in projects and creating summaries. Active learning forces us to organize our thoughts, to find the gaps in our understanding, and to make connections between the new information and the existing knowledge in our brains. Which leads us to the next point, the Feynman technique. Richard Feynman was a Nobel Prize-winning physicist who made significant contributions to the fields of quantum electrodynamics and particle physics. He was renowned for his ability to explain complex scientific concepts in simple, intuitive ways, which led to the development of the Feynman technique for learning and teaching. The Feynman technique, which is named after him, basically involves explaining a concept in simple terms to yourself or to your cat, for example. When you break down complex ideas into simpler concepts and teach them, you solidify your knowledge, and it helps you find the gaps in your understanding. Even when you understand something when you read it and you think there is no way that you could forget it because it makes so much sense, you might still be missing some vital details, which only becomes apparent when you try to reproduce the concept yourself. And mean multiple choice questions rely on this tactic by presenting familiar sounding options that can confuse you if you haven't fully grasped the details, which eventually makes it easier to mix up answers. The next technique is spaced repetition. Hermann Ebbinghaus is a German psychologist best known for his pioneering work on memory and forgetting in the late 19th century, particularly through his discovery of the forgetting curve and the spacing effect. The forgetting curve describes how information is lost over time when there is no attempt to retain it, while the spacing effect describes how information is better recalled when the learning is spread out over time instead of crammed in a single session. His findings continue to be expanded upon and supported by research to this date in what became to be known as the spaced repetition technique. Basically, this technique means reviewing information at increasing intervals over time, and research suggests that spaced repetition can greatly improve memory retention compared to cramming. For example, researchers at York University found that when students took a review test 8 days after the lecture, they performed much better on a final test 5 weeks later compared to those students who took the review quiz just the day after the lecture. This suggests that spaced learning enhances memory retention much more effectively than studying intensely over a short period of time, for example, just the night before the exam. Next, we have the Pomodoro technique. Now, you might have heard of it. The Pomodoro technique was developed by Francesco Cirillo in the late 1980s and was named after the tomato-shaped kitchen timer that he used. Basically, this time management method involves working in 25-minute sessions followed by 5-minute breaks. Then after you do 4 such sessions, you take a longer break, for example, 15 minutes. And this structure just helps to optimize focus and prevent mental fatigue, but most importantly, it will prevent procrastination. Because if you know that you only have to work for 25 minutes, it's an easier task than sitting for 4 hours straight focused to finish a task, so your brain is just less likely to try to avoid it. There are several studies that demonstrate the effectiveness of this method. For example, in one study, participants were given a 50-minute task that required continuous attention and higher cognitive load. They had to identify certain patterns across a series of images. Now, the participants were divided into two groups. One group worked on the task for 50 minutes straight, and the other group was allowed to take intentional short breaks. They found that the group that took short breaks performed significantly better and retained their attention and focus throughout the task. This supports the idea that if you have a longer task that puts a lot of cognitive strain on your brain, you would perform much better by taking brief planned diversions. In my own experience, I find that if I do take a break, then it helps if I decide beforehand on the next step for when I come back after the break. What this does basically is reduce the mental effort required to decide on the next step once you come back after the break, which ultimately reduces procrastination because making decisions, even small ones, requires effort from the brain, and the brain doesn't like that very much, so it just tries to avoid it as much as possible. So by deciding on that beforehand, you make the process of continuing with the task much easier. Now I would like to talk in more detail about my own experience and how I applied some of these techniques back when I was a student, which helped me maintain a top performance, and how I continue to apply them now in my professional life. So back when I was a student, I did not know anything about any of these techniques, but I still applied them unknowingly because this was simply what worked best. So basically, if I had a course consisting of 45-minute lectures 3 times a week, after each lecture, I would go over the material in the textbook, section by section in small chunks. First, I would read it to understand what it's about, and then I would try to explain it to myself, or just summarize it in my own words. Here, I would recognize what I'm missing, and I would go over it and read it again, and only after I managed to explain it to myself flawlessly can I move to the next section. Then on the weekend, I would go over the material we covered for the whole week again. So the first thing I would do is just to look at how much material I need to study. For example, if it was a chapter of 8 pages, I would divide those pages and dedicate a certain amount of time for each. For example, I might decide to study 2 pages in 1 hour, after which I am allowed to take a break. This means that if I was able to finish 2 pages faster, then I can just start with a break. So basically, I stayed focused and motivated because it simply depended on my pace. Then when the time for the final exam comes, like 4 or 5 weeks later, all I have to do the night before the exam is just scroll casually through the pages, only to realize I already know all of it. Now, this method that I use pretty much encompasses the Feynman technique, spaced repetition, and a modified version of the Pomodoro technique, which might be more in line with Parkinson's law. It pretty much states that the task expands to occupy the time allocated to it. So if you give something 10 hours, then it will take you 10 hours to finish it, even though it might realistically take only 30 minutes of focused work. That's why even now, as I continue to need to learn new and challenging things all the time, I still very much use this concept and apply the same methods. And you could too, whether you are a student or a professional. Find the format that works best for you and mix different techniques into a tailored recipe for your learning style. Now let's talk about some common mistakes that make it more challenging to learn and remember difficult things. One big mistake is procrastination. Waiting until the last minute to learn something difficult can lead to cramming, which is much less effective than spaced repetition, and often does not result in retaining the information long after the fact. But that's only the mild side of it. The dark side of procrastination is what is known as cognitive distortion, where our perception of the task becomes skewed. This is because we mentally build up the task, mostly prompted by anxiety, imagining worst-case scenarios and overestimating the effort required. And as the deadline approaches, the urgency increases, making the task seem more overwhelming and difficult than what it initially was. So to avoid all that, try to rely on spaced repetition instead and dedicating enough time to smaller chunks of the material, instead of trying to learn everything in a small amount of time. The second mistake is trying to learn too much too quickly, which can lead to exhaustion and decreased performance. It might work at the start, but you cannot sustain it over longer periods of time, and eventually it will lead to burnout, and it will eventually set you back and be counterproductive. Next, we have the illusion of competence, or when you feel like you understand something just because you recognize it when you see it. Again, this does not equate with adequate or lasting understanding. So if you want to really engrave information in your brain, then the methods that we talked about, especially spaced repetition, would be key. What is the most challenging thing that you are trying to learn right now? Let me know. I would be curious to know. So if you frequently face the issue of failing to maintain consistency in your learning efforts, then you might want to watch this video that I made about this.